Good morning. Today we're going to talk about a couple more formulas that you can use when calculating exact values for trig angles that you don't already know. So today we're going to focus on the sum and difference formulas here. Here's where we're at, and I just labeled the top half of the first two quadrants of the unit circle, but we know the values for 30, 45, and 60 degree angle. But if we divide our circle into, by measures of 15, we get 24 parts. So this would help us find things like pi over 12 or 15 degrees, and then 5 pi over 12. Is that right? 4 pi over, yeah. Or 75 degrees. By using the sum and difference. So if I know 90 and I know 120 and I know 45, I can subtract the 2 to find 75. So that's what we're going to use here. So first thing you need to know is the cosine of the difference of two angles is a formula that we will give you on any of your assessments. It's the cosine of alpha minus beta, and that is cosine of alpha times cosine of beta plus sine of alpha times sine of beta, and we are going to go ahead and use that. So for the first problem, find the exact value of cosine of 15 degrees. Well, if I know that cosine is the same, 15 is the same as 60 minus 45, and I know those two values there, I can use the formula. So I'm going to set this up using the formula so that I have cosine of 60 times cosine of 45 plus sine of 60 times sine of 45. Okay, so it just goes back into that formula that we had here. And then you can type this in your calculator, which you don't really need to do. If you think of your unit circle, a 60 degree angle, we have short long, so we have 1/2 square root of 3 over 2. And then we have, for 45, square root of 2 over 2, square root of 2 over 2, they're the same. Okay, so those are our points. Remember, cosine is my x value. So cosine of 60 is 1/2. Cosine of 45 is square root of 2 over 2. Sine of 60 is the square root of 3 over 2. And sine of 45 is the square root of 2 over 2. It might be easier for you at this point if we do this in radian measure, just because that's what you're used to doing. But you should still know those values. We're going to simplify this. We get the square root of 2 over 2 plus the square root of 6 over 2. Sorry, let me fix that. Those are over 4. My bad. Forgot to multiply the denominators. And then I can combine those together to a fraction to get the square root of 2 plus the square root of 6 over 4. And that's it. That's all you're doing for that. Okay. The next problem gives us part of the formula, and I know that if I do 80 minus 20, I get 60. So cosine of 60 degrees is really what I'm using here. And I know that cosine of 60 degrees is 1/2. So just going backwards using that formula. If we were to go through and verify a bunch of identities, you could start with this first cosine identity and find the difference of cosine, the sum of sine, and the difference of sine. Again, we're going to give you all these formulas so you can use them. Okay, so we're going to go ahead and do that. First problem here is actually in radians. So now we are going to use sine and sum, they tell us the sum here, to find the exact value. Okay, and then this should say sine in it, so I need to add that in there. Okay, so we're going to find sine of 7 pi over 12, knowing that sine of 7 pi over 12 is the same as sine of pi over 3 plus pi over 4. Okay, so if you use that formula sheet that I gave you, we're using the sum of sine formula, so we're going to do sine of alpha, sine of the first angle, I'll say, times cosine of the second angle plus sine of the second angle cosine of the first angle. Okay, and again, if you think of this, pi over 3 is here, so 1/2 the square root of 3 over 2, and then pi over, sorry, that's a bad angle, pi over 4 is the square root of 2 over 2, square root of 2 over 2. So when I plug those in, pi over 3 sine is square root of 3 over 2. Cosine is square root of 2 over 2. Next part, sine of pi over 4 is the square root of 2 over 2. And cosine of pi over 3 is 1/2. I'm going to go ahead and simplify this. We get the square root of 6 over 4 plus the square root of 2 over 4, which is the square root of 6 plus the square root of 2 over 4. Okay, so really you're going to combine a few things together. First, you really need to know your unit circle from last unit. And then second, you need to be able to use the formulas here. You do not have to memorize those. Okay, last problem here, and this is very similar to what you would see on an assessment, is finding an exact value. So if I tell you that sine is 12 over 13 for a quadrant 2 angle, and sine is 3/5 for a quadrant 1 angle, you could find the volume, or the exact value of each of them by drawing some diagrams. So if I draw this first one in, let's see if I can do this using some straight lines here. Go ahead and draw this in here. Okay, so if I draw this in, if I know alpha is here, it's really bad alpha, but it's in quadrant 2, and sine is going to be opposite over hypotenuse, or y over r. I can actually go ahead and use the Pythagorean theorem to find this other side. So I could do, what do you want to call this? We'll call this is my x value, right? So I'm going to do x squared plus 12 squared equals 13 squared, unless you know your Pythagorean triples. So I get x squared equals 25, so x is going to be 5. Okay, so now cosine of alpha is going to be adjacent over hypotenuse, which is just 5/13. And actually it's going to be negative though, because my x is negative there. Pay attention to your signs. Do the same thing here for b. Let's go ahead and draw that in. Okay, we have an angle in quadrant 1, and the quadrant is very important. They give us sine of beta is 3/5. So we say opposite over hypotenuse is 3/5. And again, Pythagorean theorem, x squared plus 3 squared equals 5 squared. So x squared plus 9 equals 25. If I subtract 9 from both sides, I get 16. So my x is 4. You might know or remember that we have a 3, 4, 5 triangle there. So cosine then is adjacent over hypotenuse. Again, everything is positive there. Sine is positive there, which is why cosine is negative. So we have a positive 4/5 for an answer. Okay. Now that we know all of that, we can actually find cosine of a plus b using the formula. Alpha plus beta. And sine of alpha plus beta using the formula. So cosine, we are going to do, for our formula, cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. And we actually found all those. So cosine of alpha is negative 5/13. Cosine of beta is 4/5. Sine of alpha was 12/13. And sine of beta was 3/5. And we can actually simplify that. So negative 20 over 65 minus 36 over 65 gives us negative 56 over 65. Okay, and then using the formula for sine of alpha plus beta, we have sine of alpha, cosine of beta, plus sine of beta, cosine of alpha. Okay, and then plug those in. So sine of alpha was 12/13. Cosine of beta is 4/5. Sine of beta was 3/5. And cosine of beta was cosine of alpha was negative 5/13. So I have 48 over 65 minus 15 over 65 gives me 33 over 65. Okay, and that is what you're doing. On your sheet, there are practice problems that match this very similarly. Go ahead and do that. There are 2 more formulas here that are on your sheet. We aren't going to use those today, but they might pop up later on. So like 4 problems on your practice. There's another lesson in the next video, and then I am going to give you practice so you have time to just work in class. If you have any questions, let me know. Have a great day.